So we look at example 9 in this video. So a shaft to the blades of a helicopter transmits 1000 horsepower at 200 RPM. Determine the minimum external-internal diameters of the hollow circular section aluminium alloy shaft, and the maximum permissible shear stress in the shaft is limited to 30 megapascals. It may be assumed that the external diameter of this shaft is twice its external diameter. And we're then asked, what will be the resulting angle of twist of the shaft over a length of 2 meters, given that the modulus of rigidity G is 26.9 gigapascals. Alright, so first of all, let's convert 1000 horsepower to watts. So 1000 horsepower multiplied by 745.7 watts is 745.7 kilowatts. So here is our question again. Here's our standard formulae, and if we see we have 200 RPM, so omega then is 200 divided by 60 multiplied by 2 pi, that's 21 radians per second. Torque T is related to the power and the angular velocity. So the torque is the power, which is 745.7 kilowatts, which we just calculated, divided by the angular velocity, which is 21 radians per second, and that gives me 35,510 Newton meters. We're told that the modulus of rigidity is 26.9 gigapascals, the length of the shaft was 2 meters, and that the shear stress is 30 megapascals. Right, the diameter of the shaft is D, and the inside diameter, we're told, is half. So the external diameter of the shaft is twice its internal diameter. So that's another way of saying that the internal diameter is half the outside. So that's D over 2 is the internal diameter. If I get 2 to the power of 4, it's 16. So then I'm going to take D outside of brackets. 1 minus 1/16 is 5/16. So 1 minus 1/16 is 15/16. So there's my 15/16. So 32. So that's my second polar moment of area J. And I can substitute that back in here to this formula. Okay, so we're going to take this part of the formula. So we know what the shear stress is. We know that the outside diameter is D, so the radius is D over 2. And I'm going to substitute in for the torque and the second polar moment. So the torque is 35,510, this value here, and this is our value J. So I just got rid of the fractions, so multiply this side above and below the line by 16 32s. We multiplied above and below the line here by 2. And then we're just going to bring the D to the power of 4 up, and bring the 2 by 30 by 10 to the power minus 6. We're going to bring that down here. D into D to the power of 4 is D cubed. So if we want to get D, we get the third root of this expression. And when I do that, I get 186 millimeters. Okay, the answer we were told is 182. So this is close enough. There's probably some rounding errors. Okay. So the second part of the question was to work out the angle of twist. So I've put in my 0.186 meters, or 186 millimeters as my diameter. So D over 2 is 0.186 over 2, and everything else was given to us in the question. Again, we just cross multiply to get an expression for theta, and when we put that into the calculator, we get theta to be equal to 0.024 radians. There's 360 degrees and 2 pi radians, so 1 radian is 360 divided by 2 pi. 0.24, multiply both sides by 0.024, so 0.024 radians is equal to 360 all over 2 pi multiplied by 0.024, and that works out to be 1.4 degrees, which again is close enough to the answer.